Hello, in this video I'm going to talk about implicit differentiation in relation to the product rule. Right, so you can see here we've got an implicit equation. It's very messy in terms of the relationships between x and y. So we need to use implicit differentiation here. So we're going to start by, this isn't so much an introductory tutorial. I'm just going to focus on the use of the product rule. An effort to consolidate any knowledge in case one is struggling to nail it down. So we're going to differentiate. So let's start with the first term here. So that's going to be 6y, right? But we need to write that it's by dy by dx. And likewise, if we differentiate this, that's just going to be minus 2. But again, we have to write d by dy by dx for our y terms, as one will know, in using implicit differentiation, or in differentiating implicit equations. So, because we are differentiating with respect to x, right? So, and then we've got an x term here, so we can just, well, here's the parts where there's the product rule, and so what I would like to do is let's differentiate the y first. So we can just throw some brackets down, and we can say it's going to be dx, or 2x times dy by dx, right? Because this is just 1. This just differentiates the 1. If you're and so we can just write the 1 here is implicit, and that's going to be plus. Now we differentiate our x term. That's just 2 times y. Right, so that's just the basic product rule. And then we differentiate this x cubed term, we get 3x squared. Right, so now one will know that you want to collect your collect like terms in essence, your dy by x terms on one side and the other side. I think here that we can probably, let's just subtract this 2y, and I'm just going to rearrange things a little bit. So we've got our 3x squared, right? I'm just switching things around, but we've got our 3x squared, and we're going to subtract 2y on both sides, so we get minus 2y equals all of this here. And if we factor out our dy by dx, we get 6y minus 2 plus 2x times, and you always put dy by dx at the rear. It's always what I do, at least. And now we divide both sides by everything in the brackets, because the goal, of course, is to make dy by dx the subject, and thus we get dy by dx equals 3x squared minus 2y. All of that over 6y minus 2 plus 2x. You could factor, you can't really simplify it, all of this anymore. You could factor out a 2 here if you really wanted, but I don't think that's necessary in this case. I would just leave it like this, just like this, and that would be our answer. So the big thing to remember, I suppose, when using implicit differentiation, or when thinking about it in relation to the product rule, is you want to differentiate your y term, right, as we've done here. You multiply, so you differentiate your y term, multiply that with your x term. This is just the product rule again, and then you differentiate your x term, you multiply that by your y term, and then you just want to, down at the last step, if you're not familiar with implicit differentiation, you just collect your like terms, and you want to end up making dy by dx the subject. So